In this experiment we're going to look at integrated circuits, and we're going to build some experiments from the course notes and implement them on our breadboards. We're going to first look at the chips themselves. This is the type of chip that we're going to use, the type of chip packaging we're going to use. It's the DIP packaged chip, which means plastic dual line, the pin package. And the pins are spaced at 3/10 of an inch apart. And you can see that you have a little circle here at the very top that indicates that that's pin 1. So there's a little notch at the very top of the chip, and there's a circle there that indicates that this pin here is pin 1, so that we know how to identify it. We have to be very careful that we order the DIP package chips when we're working in our experiments and so on, and when you're doing your projects later on. There are other packaging types available. This is an SOIC, which is a small outline integrated circuit, and you can see it's of a considerably smaller scale. The inside of the chip might be exactly the same and might do exactly the same function, so just the plastic packaging and the pin layout and so on is what's different in this format. Again, it's got a circle to indicate that pin 1, but you can see it's considerably smaller than the DIP packaged chip. It is possible that the chip that we want to use is only available in a DIP package, in which case we can use a board like this. It's a converter board. It allows us to. We can use these type of legs to convert into to allow us to plug it into our breadboard. And on both sides of the board, you see this side is 0.8 dot pitch, and the other side is 0.6. So in the 0.6, this is a 0.6 millimeters. So you can see that we'd line up the chip against the channels and push the solder onto the particular pins, and then we would then be able to use these pins here in a more accessible way on our breadboard. It is possible that certain types of chips that we need to use are only available in SOIC form, and that means that in that packaging format, which means that we would have to use a converter board like this. Okay, so we're going to use the DIP format for the DIP packaging format for our experiments. So each chip has an identifying number, and here we can see that this one is the MM74HCT08N. The letters all mean something. The MM in this case refers to the manufacturer, which is Fairchild Semiconductor. It could also be letters like SN, which would refer to Texas Instruments, for example. The 74 is the way that you know. I suppose this is the giveaway in terms of finding the number that makes sense on your chip. The 74, and we skip the letters in between. 7408 refers to the particular type of chip. This is a quad 2-input AND gate, so there's 4 2-input AND gates in this particular chip. The N at the end refers to the packaging type, so we know that this is a DIP packaging type, so the N refers to DIP, the dual inline packaging type. And finally we have the HCT in the middle, which refers to the particular logic family that the chip belongs to. In this particular case, it's a high-speed CMOS with TTL logic levels, so this is the particular type of chip that we're going to be using for our experiments. The first thing we need to do is we need to connect up the power to the chip. So I've set up the rails so that we have easy access, and this particular chip, pin 7 has to be connected to ground, and pin 14 has to be connected to VCC. So here we're going to connect pin 14 to VCC, and pin 7 to ground. Okay. So our chip is powered. I haven't connected the supply yet, but the chip is powered. And then we have on our input on pins 1, 2 and 3 again, we can tell our first pin by the circle that's just visible there on the top of the chip. We have pin 1, 2 our inputs, and pin 3 is our output. So we need some way of seeing our output, so we're going to use an LED for this. So I'm just going to use an LED on pin 3. Connect the LED, well, this is a piece of wire. I'm going to bring the LED over here, and I'll just use a small resistor tied to ground as before, and then we just bridge that. Again, remember the longer leg is the positive, is connected to pin 3, and the shorter leg is connected through ground to ground through the little resistor. So now we have our circuit, and we can test it, and we can say, well, let's connect both of our inputs to be high. And in this particular case, when we turn on the power, you should see very quickly that we get a value of our LED should light. So connect pins 1 and 2, both connect both to ground, both to VCC to 5 volts. And when we turn on our power supply now, you'll see that the LED lights. I'm just going to leave the power supply lit, and I'm going to disconnect one of my inputs and connect it to ground. And there you'll see that now that it's connected to ground, the LED is off. If I do it on the same with the other pins, it'll have the same effect. You'll know from the truth table for an AND gate that both inputs have to be high for the LED to be lit. So if I again set both inputs to be high, then we can light our LED like this. Now what we're going to do is we're going to say, well, moving these wires around is a little bit awkward, so let's connect in 2 switches. So I'm just going to turn off the power and connect in 2 switches. So I'm going to use these push button switches, and just make sure you have them in the correct orientation. And we're going to connect these across. I'm going to connect the first one so that it's touching pin. It's in the same row as pin 1. So that means that I'm only going to have to connect to the other side of the switch. Just make sure that they're a little fiddly, they might come out. And I'm going to put the other switch right beside it. Okay, so we have 2 switches. Both push them in well into the boards. And these buttons are going to provide my inputs. And we should see that when our circuit is connected, that we get a high only, the LED lights, we get a high only when both buttons are pressed at the same time together. So we need to connect up to say, well let's connect up a high to this side of this pin. Make sure we go into the right place. And to the other side, let's connect up our, let's make sure it goes in. And to the other side of our switch, let's connect that to the second input. The second switch is already connected into pin 1, and we just need to connect the other side of it into our high rail. Okay, it reaches. So make sure that's going into that. Okay, so it should reach. Now we turn on our circuit. You're going to see something unusual happen. It doesn't work. And if we press the buttons, and we'll see that, well, the LED nearly always stays on, so it's having no effect. But you should see that the LED flickers on and off as it goes. So you see that it's not very stable. Now the reason for this is because well, you think about for a minute what the reason for this is. Why is it unstable? So why does it seem to flick between on and off as I'm pressing the buttons, even though with no input it should at the moment be off? You think about that.